Hey everybody and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy where we are learning networks together. And on this video what I'm going to go through is a continuation on the last video I'd done where we went through the basics and the theory of BGP or Border Gateway Protocol Communities. And on this video what we're going to do, as I said, is a continuation, but we're actually going to go into the lab and start to see how can we on Juniper Junos devices configure, use and manipulate those BGP communities to actually influence traffic engineering throughout the network in the lab that I've actually got set up. So if you haven't seen that initial video I've done on BGP communities, here's the link. I highly recommend you check it out before we actually go into the lab. So you've got a basic understanding on what these communities are, what they look like, and really the function that they serve, whether it be the well-known communities or the not so well-known communities. But other than that, let's actually just go straight into the lab and get going with BGP communities. And so here's the lab that I'm going to be using for this video. And before I actually get into the configuration on the Juniper Junos devices, specifically the VMX routers that you see on the lab, what I want to do is just go through a very quick overview as to how this network is configured and generally from a high level, what are you seeing when we get into those routing tables. So what we have from a lab diagram perspective, as you can see, is we've really got quite a few parts. We've got Enterprise A here in ASN 65100 and we've got Enterprise B here in ASN 65200. Now these are actually separated, as you can see, by different service provider networks. We've got service provider 1 here in ASN 1 for obvious reasons, and then right at the bottom we've got service provider 2 here and service provider 3 in ASN 2 and ASN 3 respectively. Now that's just obviously an overview in the lab diagram. Specifically what we are interested in and what we're going to be configuring are some specific static routes which are acting as hosts in Enterprise B. Now if we look at Enterprise B, there's actually 4 routers. We've got R18 here, R19 is on the bottom, here we've got R20 and here is R21. Now that's important because each router, R18, 19, 20 and R21, they are importing a static, or I should say exporting a static route into BGP, and it's a /32. So if I was to be a bit more specific, on R18 there is an 18.18.18.18/32. Hence I'm saying that's acting like a host because that's a /32 address, and that is configured on R18, and then we're exporting that into BGP. Likewise on R19 on the bottom there is 19.19.19.19/32 down here. And guess what, for R20 and R21 I want to write it all out, but on R21 there is a 21.21.21.21/32, and R20, or on R20, there is a 20.20.20.20/32 here. So basically each one of these routers is taking that /32 and putting that into the BGP protocol. What's happening then is that advertisement is coming through for all these networks. They're coming through service provider 1 here up the top, as well as out of the southbound, the south side of the network, through service provider 3 and service provider 2. So this 18.18.18.18/32, the 19/32, the 21/32, the 20/32, they're being advertised in both directions across the service provider networks, and they are all coming into the Enterprise A environment. And as such, all these routers here have full visibility of Enterprise B's network and all those hosts, all those /32s in that network. And so I've just tidied the screen up just a little bit. So what we're actually going to do is first we're actually going to go onto this router here and this router here, just so you can see that the router here R5 and R10 have full visibility in all those /32s within Enterprise B. Either they could get to it this way, or they could get to it this way, or R10 could come up here, or R5 could come down here and get to the networks via that route as well. Now what we're then going to do is go onto each one of these routers here, which is going to be R18 and R19, and we're actually going to configure those community values. And if I was to be a bit more specific, and again, if you haven't seen what a community value looks like, please check out that video I done on community theory. But in ASN 65200, one of the communities we'll configure for the 18/32 will be 65200:18. And we're also going to configure within the same community string R21 as well. Or sorry, it's R20, which is a 20/32. So then we're going to configure 65200, and I'm running out of space, 20 here. So both of these are going to be in the same community string. Likewise, on the bottom here, what we're going to do is configure these two static routes, these two hosts, these two /32s to be within the same community string, i.e. 65200:19 and 65200:21. So obviously there we're going to show on Juniper Junos how you can configure those community values, and we're then going to put them into a policy option. That's very important. For all of this to work, you need a policy statement. Without a policy statement, this is then not going to work. We have to configure within the policy options first those community values, i.e. the 65218 alongside the 65220 in one community string. And then we're going to have another community string of 65219 and 65221. Don't worry, we're going to go through this. But my point is that we need to configure those policy statements first. Then once we've configured that, we can then export those into BGP. Now, what happens at that point is those new update messages with all those network layer reachability information and those community strings, they're going to go through service provider 1 and through service provider 3 and service provider 2, which is exactly what we want. Because don't forget, as I said in my previous video, what we could do with communities is traffic engineering. With communities, any router can accept those routes, can reject those routes, can do some kind of preferential treatment on those routes, and Azure redistribute those routes into a different type of routing protocol. So when those update messages with that network layer reachability information and those community values get to Enterprise A, to R5 here and R10 down here, we're then going to start playing about with those preferences. Specifically, what we are going to do on R5 here is we are going to define the local preference to prefer to get to R18 and R20 to go this way to get to these two routers here, using those community values and the local preference. So we're going to define that to be the local preference to be something like 101. If you know local preference, you know it's one of the BGP path attributes that any router will look at. If you don't know what the path attributes are, please check out this link, or this link here using the right finger, to learn more about the BGP attributes. Now, vice versa, what we're going to do for the hosts, the static routes configured and imported into BGP on routers R19 and R21, is we're going to do exactly the same but on router R10. So we're going to configure the local preference to look for that R19 and R21 community values, and we're going to change that local preference to be 101, so it's more preferred. So R10 is then going to prefer this route to get to that destination. So with all that said and done, let's actually now go onto the Juniper Junos and see how you can configure these community strings and how we can start configuring those policy options using local preference to do that traffic engineering in Enterprise A's environment. Okay, and so here I am on R18's Junos. R18 is this router here. You can see my mouse in the background. So this is a VMX router in Enterprise A in ASN 65200. Don't know why, but secure CRT is not getting connectivity to R18. It's not important, so I'm just using the SSH on EVE-NG. perfectly fine. Let's just run with it. So let's first configure that community string. Where do you configure that community string in Junos? You do that within the policy options. Now, interestingly, you do not define the community string inside a policy statement. You do that outside of a policy statement, and then you reference that inside of a policy statement. So there's actually 3 steps we need to go through. So step 1, let's actually configure those community strings. But first, let's just do a quick show, and you can see all the policy statements that I've configured previously. So there's something here for iBGP, next hop self. If you don't know what that is, check out this link. I keep doing that, I keep getting my hands wrong, but hey, this is why I'm doing Aruba. But you can also see something for iBGP here, advertising internally and exporting a static route. All of that's fine, but we are interested in community. So first, let's do set question mark and note here community. So we want to define community. Now the next part is you need to give it a name. That community string first needs a name. So I'm going to call it R18 and R20 because we are going to be using those /32 static routes that come from R18 and R20. Now what we need to do is actually, well, if I hit question mark, you could see we could do a few things, but what we're interested in is members. So I need to reference the community members or member. If you want to do just one community member, you just enter in the value here. But what we want to do is enter in 2 community members. To do that, you need to open up square brackets with a space. Now, as per my previous video, the first part of a community is always the autonomous system number, in which case this is Enterprise B, ASN 65200, and then a value that the ASN actually provides. So I'm doing 65218 to reference that static route, that /32 that's coming from R18 within ASN 65200. We also need to do the same though for the R20. So I'm going to do 65200:20 space, close the bracket and done. So there, under the name of R18_R20, the members are with those community values. And now that's actually it. So if I do show, you can see right at the bottom, we've just created our community string with these members. But we need to put that into a policy statement. Now to do that, I don't want to create any routing loops. So I'm actually going to configure a new policy statement. So I'm going to do set policy statement. We need to give it a name. So I'm going to call this export com for communities. Term 1 from route filter 18.18.18.18/32 exactly, and 19.19.19.19/32 exactly. Then I need to do something with this. So I'm then going to say set policy statement export com term 1, then community, hit question mark, add, and now I need to give the name of that community string I just defined, I just created up here. So I'm referencing the name here to the community string and members I configured up here. And just to be sure, then accept. And now if I do show, you can see export com here, term 1 from these route filters exactly. I've done it again. I keep doing this. We don't want route filter 19.19.19/32. We need R20, don't we? The 20/32. So let me just do edit policy statement export com. Let's delete term 1 from route filter 19.19, not 10 exactly. And now let's do set term 1 from route filter 20.20.20.20/32 exactly. Let's go back up 1, do show. And there we go. That looks better now, doesn't it? It's just natural habit. Counting, you do 18, 19, then 20. So I'm skipping the 19, but my brain's just not working that way. But anyway, we've got the policy statement here, export com from these route filters exactly. Then add these community values, which are referenced down here, and we want to accept that. So that's actually the second step. The third step is taking this policy statement of export communities and exporting that into BGP. So let's do top, edit, protocols, BGP. Let's do a quick show. And you can see all the configuration I've done on previous videos, but we need to export this into the external connectivity because R18 here is passing this to this router here, which is in the service provider, and that is in a different autonomous system. So this is iBGP. So we need to reference that community policy statement in external ASN1 for obvious reasons. So let's do set group external export, hit question mark, and there is the community there, the policy statement with that community string export com. Let's do a quick show, and I could do a quick commit check, and it works out, and I'm just going to commit to that configuration, and that is actually the configuration done on R18. Now we need to do the same on R19, but referencing the 19/32 and the 21/32, because don't forget on, let me get rid of this, on Enterprise A's network we want to configure different preferences to get to those different routes, those different prefixes through the service provider networks from router R5 at the top and router R10 at the bottom. So let's actually go on to R19, and I'll just bring up my secure CRT. So here we are on R19, and note R19 is the router down here, and I'll just go into the command line interface. I'm going to do a bit quicker this time. Not show, let's do it, go into configure mode, edit policy options, and now I need to say set community. We need to give the name, so I'm going to call it R19_R21 members, open up the bracket, 65200:19 space 65200:21 space square bracket again to close it off, and that's it. And now I need to define the policy statement, so set policy statement export com. I'm just going to call it export com again, term 1 from root filter 19.19.19.19/32 exactly, and from 2021.21.21.21/32 exactly. Then we are going to add that community string. So then community, hit question mark, add R. Actually, does it show up yet? No, we've still got to give the name manually, so R19, but I remember it, and R21. And finally, then accept. And I just want to do a quick show on that policy statement, show policy statement export com. And there you can see it there. So from R19, this router down here, we're filtering on the 19/32 exactly, the 21/32 exactly. We're adding that community string of R19_R21 and accepting that. And if I just show you the community string, it's right down here at the bottom. And now we need to import that, or export that into BGP. So let's do top edit protocols BGP, and let's do set group external, because this is going to external autonomous system 3. If I move secure CRT out of the way, R19 has 2 eBGP connections over lag. If you don't know what lag is, let me get it right. Hey, I got it right. Check out this link, good old YouTube. It's got a lag connectivity to the router here, R17 in ASN3. Set group external ASN3, and I want to export, hit question mark, there we go there, export com. Let's just do a quick show, make sure I'm happy with that. And here is our eBGP type external, advertising internal, advertising some aggregate route as well. I'm not going to worry about that. And then export com is the policy statement we've just done. Let's do a quick commit check, and that works. I'm now going to commit that configuration. And with that now passed, let's just have a quick refresher. So what we have done is we have configured I'm just going to make that brush a bit thicker. It's too thin for my liking. So on router R18 here and on R19 here, we've configured those community strings, and we've imported those into a policy statement. So on R18, we've got the 18/32, and I'm going to get it right, the 20/32, where hey, I got it right, and that is being sent through service provider 1's network. Likewise, but slightly differently, on R19, we've got the 19/32 and the 21/32, which has been exported into service provider 3's network, and it's going to go all the way through service provider 2's network. Now what we want to do is go onto these routers here, R5 and R10, and actually see first, are we seeing those community strings in those update messages for the 18/32, the 19/32, the 20/32, and the 21/32? And then we want to start playing about with local preference so we can do some form of traffic engineering. And so I've logged onto the router R5, which is this router just here. And all I want to do is see on the command line interface, do we actually see those community values inside of those BGP update messages? So first, let's go into the command line interface, and there's a simple command that you can do, such as show route. Now that's going to show the 18/18/18/32, the 19/32, the 20/32, and the 21/32. But we've seen this before, and there's no real detail here. Yes, it's nice. It says BGP and the administrative distance, and what interface it can go out of, the paths and the next hop, etc. But what we need is, and there's a hint here, is an extensive, see what I've done there? An extensive detailed approach. So if I do the same command, but now I want to see what routes have I received from the protocol BGP. Now the next part of this command is you need to define the neighbor IP address. So if I move secure CRT out over the way, we can see the adjacent IP address on the adjacent interface on router R1 here is 170.10.20.2. So if I just enter in that here, 20.2, and here's that keyword extensive. And this is now going to show me the extensive information for all routes that I've received via BGP, but from the iBGP neighbor with IP address 170.10.20.2. And if we hit that now, here we go. This is exactly what we need to see. Here is the 18/32. It's accepted. The next hop is the BGP peer. It has come from the Autonomous System 65200 where it's originated from, and there's two ISN ones. I've prepended an ASN to make the paths equal. But now we can see those community values that we put into router R18. 65.218 and 65.220, and we can also see exactly the same for the 20/32. So that is absolutely perfect. But what about R10, which is this router just down here? So let's actually go on the command line interface and check out that routing table there. So if I go into the command line interface and to show route received protocol via or from BGP, I just need to drag secure CRT out the way to check the IP address. So again, this is the IP address on the interface for the neighbor that's adjacent to this router. So we've got R10 here. Here's the adjacent router in ISP2 or ASN2, and that IP address is 170.10.20.6. And again, we need to do extensive. Now, but here we're looking for the 19/32 and the 21/32. Here we go. We can see the 19/32, the next hop IP address, the autonomous systems it's come through. So it originated in 65.200, then passed through ASN3, ASN2, and here are those community strings right here. 65.200:19 and 65.200:21. And we've got the same for the 21/32. So now that this router here can see across ASP1, ASN1, the group of community strings I configured here, which was 65.218 and 65.200:21, or sorry, :20 I should say. And this router here can see across the network this group of community strings here, which is the 65.200:19 and :21 there. Now we want to do that local preference on these routers here to actually influence that local engineering of traffic, i.e. if I'm on this router here and I want to send, or this router here and I want to send traffic to any one of these destinations, which way am I actually going to exit my autonomous system? And the configuration to do so is incredibly straightforward. First, we obviously have to go into configure mode, and we need to define those community strings because we need to match those community strings. And then we need to define that policy statement where we're going to do some form of local preference. So let's do set policy options community members community, hit question mark, and I'm going to give it a name. So I'm going to call this R18 and R20 to keep things the same, of course, across the different networks. And I want to then do members, open it up, 65.200:18 space 65.200:21 20, close it off, and that is my community values actually defined, and we can actually see them all the way down the bottom here. But just like before, we then need to define, and as I just said, we need to define a policy statement. So if I do edit policy options, policy statement, and I'm going to call this local pref for local preference. Now if I do set term 1 from community, and here you don't actually define the community string. Junos doesn't work that way. You need to define the community name. So I need to reference community name R18 and R20. So, but if I hit question mark, you can now see it's going to say, well, put in the BGP community. So you don't enter in here these BGP communities, you actually enter in the name. So I'm going to call this R18, R20. And then I'm going to say set term 1, then local preference 101, then accept. And if I just do a quick show, and I could even be a bit more specific and say set term 1 from protocol BGP. And if I do a shell command again, so here is saying if any for any packets, for any update messages in this specific case that come through that is protocol BGP and matches the community strings that are within the name R18 and R20. So if I scroll back up, that is the 65200:18 and 65200:20. Then I want to make the local preference 101 and accept that. So at this point, we have our policy option defined, our policy statement defined, that is taking a community name which has those community strings, and we are then saying, well, if a router comes via protocol BGP and has those community strings, then we want to do something with it. But at this point, we now need to take that policy statement and put that into BGP. Now here is a big learning point. This will catch you out. These routes are coming in via iBGP because they've come from Enterprise B, really this router here, and it's gone through service provider 1's network, so on and so forth, to eventually gets to this router and out it goes to Enterprise A. Now this is the iBGP peering, whereas inside Enterprise A, everything is running iBGP. So how are we going to take those communities, those prefixes, that and really that policy statement, and get that from eBGP into iBGP? And really what I'm getting towards is that we need to do the import, not the export, but the import on that eBGP peering. Because these prefixes, these communities are coming from that eBGP peer, from ISP1 into Enterprise 8, from this router to this router here, those routes are there, those prefixes are there, and we need to take that away from that eBGP peering, from that session, and put it into our iBGP peering, into our iBGP network. Hence we have to do import, because we're importing it from eBGP into our routing table. When we do this import, all those communities, all those prefixes are going to be imported into our routing table. And at that point, it's then going to be populated into the forwarding table, down to the packet forwarding engine, and thus it will go into our iBGP network. So we have to do this third and final step on the eBGP group, and we have to do import. If you do export, you're not going to see any success. All these routers here will learn of those communities, but they won't see that local preference. They won't see that manipulation that we've done on router R5 here. So back on router R5, which is again this router just here, it's not highlighted. Let's go into the command line interface, and what we have to do is go into configure mode, and let's do edit protocols BGP. Let's do a quick show, and here you can see my external eBGP network, iBGP. And here you can see my internal eBGP, iBGP. Now, as I just said, we need to set this as an import function on the external BGP. So let's do set group external AS1 import local preference And that's it. That is the third and final step. So obviously very quick, very easy that, but it's important you understand that we need to import that from the iBGP peering, from all those routes and communities and prefixes I learned. We need to import that into our routing table. And now if I just do a commit on this, and with that committed, how are we now going to verify that R5, this router, is forwarding those prefixes, but with that changed local preference of 101? Well, if you were to say run show route advertised protocol BGP, this wouldn't be correct actually, because this is showing all the routes which we are advertising on BGP, but before a policy statement has actually taken place. So we actually need to do this on just show route. So the command we're going to do is run show route, and I'm just going to go on to 18.18.18.18/32, and here you can actually see now, so this is what we are actually advertising out of router R5. So we could see 18/32 going to this destination here, so that's the next hop for the iBGP peer, but we're advertising this internally as a local, with a local preference of 101. And if I do the same for the 21/32, and I've done it again, it's the 20/32. I don't know why I keep doing that. And there we go here. You could see the local preference of 101 there. So those are the three steps which I've just gone through in quite a bit of detail. On R10 now, which is this router down here, we are going to do exactly the same, but a bit more quicker. So let's go into the command line interface, into configure mode. And first we need to define those community values. So let's set community. Let's call this R19_R21, just to keep things consistent again. And now we need to enter in what are those community values. So 65200:19 space 65200:21 space, end the brackets, and that's it. If I do a quick show, we can see our community members and the string is created. Now we need to define that local preference. So it's not this one here, LP for short, that's for something else, just coincidentally. But let's actually now set that policy statement. Let's call it local preference term 1 from community. We need to give the name R19_R21. And I can even say from protocol BGP. Then we want to say then, and I'm just going to give this a local preference of 102, just so it's a bit different to this policy statement here, just so I could differentiate. Then local preference 102, then accept. And if I show that policy statement, you can see this is done. Now we need to do exactly the same on R10 that we've done in R5 in terms of importing those externally learned prefixes and communities into iBGP, or really more specifically into the routing table, but then it would be drip fed into iBGP. So let's go top, edit protocols, BGP. Let's do a quick show. Here are my iBGP and my eBGP, tongue twister. Let's do set group external import local preference. Let's do a quick commit on that. And with that succeeded, now we just do run show route, and let's see if this is working. 19/32. And there we go. You can now see there's that local preference of 102 for the 19/32. So that is what we are advertising out of router R10. That is after that policy statement has taken effect. And let's do the same for 21/32. And again, you could see that information there. And just to be sure, let's actually just go on to any one of these routers. So let's say router R6. And I've just highlighted the router so you could see which one I'm actually referring to. But let's see, does it receive those prefixes with those communities, but with now that adjusted local preference of 101 or 102, depending on which prefix we're actually talking about. So let's go into the command line interface. Let's do show route just very quickly. And here, note, for the 18/32, we've got a local preference of 101. For the 19/32, we've got a local preference of 102. For the 20/32, 101. 21/32, local preference of 102. So what does all of this actually mean in summary? What this means is that on these routers here, on R5 and R10, we've taken in those community strings via eBGP imported that into our routing table, and because we've set a specific local preference, we are thus impacting for these routers what route that they can take to get to any one of those destinations. So if we look at it from, again, R6's perspective, if it wants to get to 18/32 or 20/32, it's going to take this destination or this route here to get to those destinations. Likewise, for the 19/32 and the 21/32, if it wants to get to those destinations here, it's going to go down to router R10 through service provider 2, through service provider 3, to eventually it gets to its destination. That is how we can use community strings with policy statements and import that into our routing table to influence how traffic exits an autonomous system using BGP. But what about well-known attributes such as no advertise, no export? So first, for these BGP well-known communities, let's concentrate on the no advertise community. Now, if you don't know what that is, again, I highly recommend you see the last video. The link is down in the comments box. But in a brief recap, what the no advertise does is, if we look at it from this router's perspective, R18, where it's advertising that 18.18.18.18/32 into BGP, it's coming across the network here and it's eventually reaching router R5 here. Now, with the no advertise community, this router is aware of this /32 all the way across in Enterprise B's network, but it is not then going to advertise onto this router or this router or this router here. And as such, all these other routers in Enterprise A, the only way they can get to the /32 on router R18 is to go through this router here, through service provider 2, through service provider 3, and eventually get up to that 18/32 that way. Now, there are specific use cases as to why you'd use a no advertise, such as you've got an aggregate route and a more specific route being advertised in from a service provider network into your enterprise, and you don't want to advertise that aggregate route throughout your autonomous system, but you do want to advertise the more specific route perhaps. So there are use cases as to why you do this, but what we are actually going to concentrate on is how to configure, obviously on Junos, the no advertise community. So I'm back on router R5 now with a fresh command line interface. I've just drawn what that router is on the EVE-NG environment, just so you know what router I'm actually referring to. Now, to configure no advertise and even no export in Junos, it's incredibly straightforward. This is not going to take long. But first, it's going to the command line interface and into configure mode. Now, it's going to edit policy options. Now I need to define a new community string. So I'm going to define set community. I'm going to call this no advertise for obvious reasons. Now I need to define the members, and to do a no advertise community, well-known community I should say, you've got to write it like this. You've got to write no advertise here. And that is quite literally how you define that no advertise community. You give it a name, you define what the members are, and here we're going to say no advertise. Very straightforward. But just like we did in the previous lab, we then need to reference that inside of a policy statement. So I'm going to create a policy statement called no advertise, again for obvious reasons. And let's do set term 1 from route filter 18.18.18.18, not 19/32 from protocol BGP, and set term 1, then community no advertise, and then accept. And now if I do show on that, we've then got our no advertise community actually defined, where it looks like it's not actually doing, I've missed it out here. I missed the keyword exact. So let's just hit up a few times, and here we go. Let's do exact, do show again. That looks better. I knew there was something missing there, but under this policy statement of no advertise, term 1 from protocol BGP, anything that matches on the 18.18.18.18/32 exactly, don't forget that, then I want to accept that. Missing the community as well, so let's then do set term 1, then community add, no advertise, and do show. And there we go there. It's all complete. Missed out 2 words there, but we're all human. That's why we do these labs. And just as we've done before, we then need to reference that policy statement inside of that iBGP connectivity, because that 18/32 is coming from service provider 1 from ASN 1 into enterprise A via iBGP. Hence, we need to import that into our routing table. So let's go to the top and edit protocols BGP, do the show, and what you can see is there is our local preference policy statement that we defined before. Now I'm going to delete that, so I'm going to delete group external import local preference. I'm going to set the group external ASN1 import no advertise. Let's do show, and there we go there. It's now importing from iBGP into the routing table. And once I commit this, what we should see on the other routers, such as router R6, is it should no longer see 18.18.18.18/32 through router R5. R6 here is still going to see the 18/32 over here, but it's not going to be via this route here because of that policy statement we've defined on router R5. But as I said before, it can still get to the 18/32 via this route here by going through router R10, through service provider 2, through service provider B3, and then getting into enterprise B's network that way. And here we are back on router R6 now. So let's just do a quick show route and see what we can see. So we can see the 18.18.18.18/32, but note now it is not coming from or through service provider 1's network, through this router here. It is only learned of that route via the AS path from service provider 3 and service provider 2, where it then originated in ASN 65200. Note the local preference has changed from 101, I think it was, back to 100 because we removed that policy statement. Now I can, just to reinforce this a little bit more, if I actually do a show route received protocol BGP from the neighbor 200.10.100.5, I think it is, what we can see now is that it's not even receiving the 18/32 via router R5 here. It's just not seen at all because we're seeing the 5/32, the 20/32, which is correct. That should still be getting through. And all these other networks, but I don't know who the 55555/32 is. I have to look into that. But we're still getting the 20/32, R20 through, but the 18/32, the R18, is being blocked. It's not being advertised by router R5. That's it. That's literally all you have to do on Junos to configure a well-known no advertise BGP community. But what about the BGP well-known community no export? And just as a quick recap, what that is when you've got prefixes coming into enterprise A, the no exports defines this router R5 can advertise it to R6, can advertise it to this router, this route reflector down here, and can even advertise it onto this router here. And just let me remove my secure CRT. But this router here is then not going to advertise it on to ASN2. So what no export basically means is the learned routes stay within inside that autonomous system itself. It's only advertised to iBGP neighbors. It is not advertised to eBGP neighbors, and thus you stop your network becoming a transit network. And there's plenty of use cases as to why you'd want to do that. And back on router R5 now, if I actually now just go back into the top, edit policy options, noting the same pattern here. And let's do a show, let's see what that community was. So here we've got community no advertise members with no advertise, but now I want to create a community called no export, again for obvious reasons, with the members, and you have to write this specifically like this, no export. And the second step is we now need to define that policy statement. So I'm going to edit policy, spell it correctly, policy statement no export, and I set term 1 from protocol BGP route filter 18.18.18.18/32, and I'm also I've done it again exactly, and the 19 or 20 I should say the 20.20.20.20/32 exactly. I'm not going to forget it this time. And now I define set term 1, then accept, but also set term 1, then community, no export. And just to do a quick show on that, make sure I've got everything there. So set term 1 from protocol BGP, I'm looking for the 18/32, the 20/32 exactly. If it matches from this and operation, so and BGP and this route, then I want to add the no export community and accept this into my routing table. Again, the third and final step is to put this into that iBGP, that external border gateway protocol routing adjacency from enterprise A into service provider 1. So let's go to the top, edit protocols, BGP, and it's delete. And actually I'll do a quick show so you can see the group. So we've got the group here and I need to delete the import no advertise, delete group import no advertise, and now let's set the group external import no, and there we go there, no export. Commit to that configuration, and there we go. That is all you have to do to configure two well-known BGP communities. I'm not going to be able to show you the sub-confed no advertise community because I've not configured it yet in this environment, but well, I'll do that in due course. But how quick and easy is that on Juniper Junos? Very straightforward, very easy. In policy options, configure the community name and the members, define that within a policy statement, and then import that within the BGP protocol itself to import that into the routing table. That's it. And so there we go, everybody. That's the end of this video. I hope you found that informative. I hope you found that useful. There was a lot of information that we went through on how to configure BGP communities, both the standard communities and two of the well-known communities. But in short, there are 3 steps to doing so. Step 1, you configure the communities, the members, the name within the policy options. Step 2, you configure the policy statement to take some action with that community, i.e. the local preference, or maybe matching on a route filter and doing no advertise. We need that policy statement. And step 3, we then reference that policy statement in the import function on iBGP. But that might be different depending on your use case. Nonetheless, as always, I hope you found that useful. If you have any questions or comments, let me know down in the comments box. I love hearing from you guys. Other than that, please subscribe, please like the channel, and stay tuned for more. Thanks for watching.